This video will be about carbon-carbon bond formations with aldehydes and ketones. So technically speaking, any carbon nucleophile should react with a carbonyl because carbon nucleophiles or carbanions are relatively unstable and therefore pretty reactive. So name me a easily and readily made carbanion. If you said deprotonated alkyne, you are correct. So if we take an alkyne and we add a strong base to it, we call this NaNH₂, we can deprotonate the acidic proton of the alkyne to give us a carbanion, which in this case is very ideal as a nucleophile because it's linear, recall that. So if we were to react this with a carbonyl, it should not have any problems. It will attack on the carbon that is most electrophilic and kick out one of the two carbon-oxygen bonds, giving us an intermediate, which we can then work up with an acidic solution to yield us the product. It's important to note that this reaction is not an equilibrium, and once we form that carbon-carbon bond, there is no going back. So once again, we have now extended the length of our chain, and we can now further modify it because remember, we have plenty of reactions that we can do on the triple bond. So this is pretty exciting. We can make very complex molecules from a simple deprotonation of an alkyne followed by a nucleophilic attack on a carbonyl. So let's look at an example. We can react acetophenone with butyne obviously along with a strong base such as sodium amide. And then we need to follow it up with an acid wash just so we get a protonated product. We don't want to really isolate an alkoxide, yielding us this product. We'll go over the mechanism just to emphasize how this happens. Initially, the butyne gets deprotonated, forming our reactive anion or nucleophile, which can then react with acetophenone voila, to form that carbon-carbon bond. This will yield us the alkoxide product, which can then further protonate when we add an acid to it. To yield a final product. Now, what other carbon nucleophiles can we have? That will be the subject of our next video.